Data is all around us. It's in the books we read, the websites we visit, and even the weather reports we check. In the world of computers, data is the lifeblood of everything we do. Understanding how data is organized is crucial for anyone who wants to work with computers, especially programmers. This is where the concept of data hierarchy comes in. It's like a ladder, starting from simple pieces of information and building up to massive collections of data. Think of it this way. Imagine you want to build a house. You wouldn't just start throwing bricks together, would you? You'd need a plan, a structure, a way to organize all the different parts. Data hierarchy provides that structure for information in the digital world. Just like a house has rooms, walls, and bricks, data has its levels of organization. By understanding this hierarchy, we can work with data more effectively, from writing simple programs to analyzing huge data sets. Let's start with the smallest unit of information in our data hierarchy, the character. Characters are the letters, numbers, and symbols that we use to communicate. Every word, sentence, and paragraph is built from these basic building blocks. In the computer world, characters are represented by binary code, a series of zeros and ones that computers understand. Data, on the other hand, is a broader term. It encompasses any collection of characters that have meaning and context. For example, the letter A on its own is just a character, but when combined with other characters, it can form words like apple or amazing, which convey specific meanings. Data is all about taking these raw characters and turning them into something meaningful that we can use and understand. Moving up our data hierarchy ladder, we encounter the concept of a field. A field is a single piece of information about a specific entity. Think of it like a label on a box. That label tells you something about what's inside the box, right? A field does the same thing for data. For example, imagine a digital library card. Each card might have fields for your name, your library card number, and the date your card expires. Each of these fields provides a specific piece of information about you as a library member. Fields help us organize data to meaningful categories so that we can easily access and understand it. Now let's combine multiple fields related to the same entity. This collection of fields forms a record. Think of a record as a complete file folder containing all the information about a particular person, place, or thing. Going back to our library card example, a single record would contain all the fields associated with your library membership. Your name, card number, expiration date, and perhaps even a history of the books you've borrowed. Records provide a holistic view of an entity by grouping related data points. They allow us to see the bigger picture instead of just isolated pieces of information. Imagine trying to understand a customer's purchase history by looking at individual fields like product name or purchase date scattered across different files. It would be much easier to make sense of that information if it were organized into customer records. Section 5. Files, organizing our records. As we accumulate more and more records, we need a way to store and organize them. This is where files come in. A file is a collection of related records stored together. Think of a file as a filing cabinet drawer. Just like a drawer can hold multiple folders, a file can contain multiple records. For instance, our library might have a file called Library Members that contains a record for every single member. This file acts as a centralized repository for all member-related information. Files provide a way to manage large volumes of data by grouping related records, making it easier to store, access, and manage. Section 6. Tables, rows, and columns of data. In the world of computers, we often organize data in a structured format using tables. A table is a collection of data organized into rows and columns. Each row represents a record, and each column represents a field. Think of a table as a spreadsheet. You have rows of data, and each cell in a row corresponds to a specific field. For example, our library member data could be easily represented in a table. Each row would represent a member, with columns for their name, card number, and expiration date. Tables provide a clear and organized way to visualize and work with large data sets, making it easy to sort, filter, and analyze information. Section 7. Databases, a home for our tables. As our data grows even larger and more complex, we need a more robust way to manage it. This is where databases come in. A database is a collection of related tables, along with tools to manage and access that data. Think of a database as a giant library that houses all of our data tables. For example, our library might have a database that contains tables for library members, books, loans, and more. Databases provide a centralized and efficient way to store, manage, and retrieve vast amounts of data. They allow for complex queries, relationships between different data sets, and ensure data integrity and security. Section 8, Data Warehouses, the big data picture. At the very top of our data hierarchy ladder, we have data warehouses. A data warehouse is a massive collection of data from multiple sources used for reporting and analysis. Think of it as a giant data repository that combines information from various databases and external sources. For example, a large bookstore chain might have a data warehouse that combines data from its sales transactions, customer profiles, inventory management systems, and even market research data. Data warehouses allow businesses to analyze trends, make informed decisions, and gain valuable insights from their data. Section 9, Conclusion, Data Hierarchy in Action. Understanding the data hierarchy is essential for anyone working with data, from beginner programmers to seasoned data scientists. Just like a builder needs to understand the different parts of a building, programmers need to understand how data is structured to work with it effectively. By breaking down data into its constituent parts, from characters to data warehouses, we can gain a deeper understanding of how information is organized and used in the digital age. As you continue your programming journey, remember the data hierarchy. It's a fundamental concept that will serve you well as you learn to build, analyze, and interact with the ever-growing world of data.